Welcome to Ask and Learn.
A gasoline engine has an output power at 180 kilowatts. It has a thermal efficiency of 28%. How much heat must be supplied per second, and how much heat is discarded per second. Okay, so this problem gives us power. And then as a reminder, to relate power to energy, you do power is basically like some kind of measure of energy per unit time. I guess it's the derivative of energy with respect to time. And so if we're concerned with just 1 second, we can say that, or what's going on for 1 second, we can say that the work output is going to be this power, which is this 180 kilowatts times time. Yeah, actually, I'm going to use consistent symbols and just call this work. Although I would say more generally, it's probably energy per unit time. But in our case, they tell us basically that the work done by this engine is 180 kilowatts times time. Okay, great. So then for the work, then you get, since the time is just 1 second, I guess I'll go ahead and put time equals 1 second on this list. Then it's just 180 kilos, so that's times 10 to the 3 joules. Okay, so once you get that, the rest of the problem is just basically plugging it into the heat engine formulas. So the first question asks for the Q hot. We want to use E equals work over Q hot, implies that Q hot is work over efficiency. Here's our work, and then our efficiency is listed over here. And if you put this into a calculator, hopefully you get the same thing I did, just 643 times 10 to the third joules. Yay, and I had room for it. And a box. So I'll go ahead and box that answer. And then for part B, you want to get Q cold. I should double check that was exactly what they asked for. Yeah, so they asked for how much heat is discarded, and in heat engines, it's cold, a lesser amount of heat, so it's Q cold. And so that's to find that, you want to actually start with the equation that work is the magnitude of Q hot minus the magnitude of Q cold. And then from that, you get Q cold equals the magnitude of Q hot minus the work. And if you just like plug in this Q hot that we found here, put like a little arrow. And then if you plug in the work found up here, add another little arrow, then just take the difference of the two, then you get 463 times 10 to the 3 joules. So it kind of makes sense. It's getting as an input of 643 joules. It's basically throwing a lot of it away, but this part that it's not throwing away is going to do useful work.